Let us take a look at another example. So in this example, we have the following. Question says, solve e2 to y minus y times cosine of x dy dx, which is equal to e to the y sine of 2x. And we have the initial condition. It says, well, when x is equal to 0, your y value must be 0. So let us try to solve this. So the very first question that we are asking is, what is the classification? What is the classification? Is it separable? If it's separable, then we need to use the method of solving a separable differential equation and solve it. And move on to step 2 to apply the method. So let's take a look at this. As you can see, you have some y terms, x terms, dy over dx on the left-hand side, and e to the y sine of 2x is on the right-hand side. Let us apply algebra and try to see if we can separate these the way that we have a separable differential equation. Very well. Pure algebra. By using algebra, well, what you can do, you can multiply both sides by dx to get rid of dx. So what you're going to get, you're going to get e to 2y minus y cosine x dy equals to e to the y sine x dx. The next is to get rid of e to the y from right-hand side and bring it to the other side, and also know that you have cosine of x. So we're going to divide everything by cosine of x and at the same time by e to the y. So what you're going to get, you're going to get e to 2y minus y dy divided by e to the y equals to sine x divided by cosine x. So here you have sine of 2x. Let me fix that, times dx. Is it separable? Of course it's separable. So what's the meaning of that? It means that we need to take the integral of both sides. Take the integral. Well, to take the integral of both sides, before taking the integral, let us try to simplify this as much as you can. You have e to the y. Let us bring it to the numerator and write it as e to negative y, multiplied by e to 2y minus y dy. And at the same time, you have sine 2x going back to precalculus. You get to sine x cosine x divided by cosine x dx. As you can see, you can cancel out cosine x and cosine x. Well, if you distribute e to negative y into parentheses, you get e to 2y minus y e to negative y dy equals to 2 sine x dx. Well, let's take the integral. The integral of both sides. Here you have e to 2y minus y, which is just e to the y, and minus y e to negative y dy. Taking the integral of the first term is not that hard because you have the integral of e to the y, which is e to the y. But for the second one, you have to apply integration by parts. So this is e to the y minus the integral of y e to negative y dy. Your right-hand side is easy. You get negative 2 cosine x plus constant of integration. Let's call it c sub 1. So in case we need to change it to anything else, we have that option. Very well. So integration by parts. Very well. So recall that. Recall. If you take u to be y and dv be e to negative y dy, then du is just dy, and then v is equal to negative e to negative y. So your integral becomes uv minus integral v du. Integration by parts. So let us copy down e to the y minus, well, here you have uv negative y e to negative 1 minus the integral of v du negative e to negative y dy. So you get a plus e to negative y dy equals to negative 2 cosine x plus c sub 1. Very well. So this integral is easy. Remember that the integral of e to the x dx is e to the x. The integral of e to minus x dx is minus e to minus x plus c. Very well. So let's write down. We have e to the y minus plus y e to negative y minus e to negative y, which is equal to, and here if you take the integral and you get a plus negative 2 cosine x plus c sub 1. Very well. So it seems like you have the solution for this differential equation, but at the same time you have an initial value x sub 0 and y sub 0. So let us plug those in. E to the power 0 plus 0, 1 over e to power 0 plus 1 over e to power 0 is negative 2 cosine of 0 plus your constant. So you get 1 plus 0 plus 1 equals to negative 2 cosine of 0 plus c sub 1. So it means that 2 is equal to negative 2 plus c sub 1, or c sub 1 is equal to 4. We found the constant, so it means that we can substitute this back here. So the solution is e to power y plus y e to power negative y plus e to power negative y equals to negative 2 cosine x plus 4. We found the solution.